Hi, and welcome to the Prelab for histology of blood and hematopoiesis. Today's Prelab is going to be kind of a guided tour version. This does not mean that you don't need to come to lab. This doesn't replace the lab. It's like any other Prelab, something that you do before you get there that will prepare you for the activities that we're going to do. So we'll start today's Prelab with a review of peripheral blood. It's been a very long time since essentially your first lab of medical school, since you've looked at peripheral blood smears. So we're going to start by reviewing them very quickly, and that way hopefully you'll be able to move on to hematopoiesis a little more easily. So when you start at a very low mag like this, the first thing you might notice is that on the left side of the screen here, the smear is extremely dense. Recall that as I zoom up here into this dense area, I'm going to see red blood cells literally on top of one another. And although you can sometimes ID the nucleated cells fairly well here, the more artifact you have for the RBCs, the worse it's going to be for these white blood cells. You can see here that this one has an artifact where it's beginning to burst. So we're going to avoid these thick areas of the smear, and we're going to search for cells over here in this more lighter smear area. So as we go up here, we see the RBCs are nicely separated from one another, and they look like they should. Nice donut shape, more or less. And the first thing you might see is that you have a lot of these cells with what it looks like multiple nuclei and very pale granular staining cytoplasm. And these are, of course, neutrophils. 3 to 5 lobes of the nuclei with very thin cytoplasmic bridges between them, and neither strongly acetophilic or basophilic cytoplasm. And there's a lot of them. They are the most commonly found cell here. You can see them pretty much all over this slide. So as I zoom down in magnification, you can see that you really just have some kind of cells with nuclei scattered around here, not really a high density of them, which is your clue that you're in peripheral blood. But even at low magnification, I can see a cell here which looks a little different. Let's zoom in on that one. And here we have a nice example of an eosinophil. Very large, brightly red staining granules, and kind of a bilobed nucleus. Some of the granules are kind of obscuring that nucleus, but generally you can see the nucleus fairly well in this cell type. So I've moved to a slightly different area in this smear, and right here you can see a number of nucleated cells, most of which have multiple lobes, so those are all neutrophils, but this one has one round centrally located nucleus and not a very granular cytoplasm, but the cytoplasm is a nice pale basophilic appearance. This is a lymphocyte. It's mostly a nucleus with a thin rim of cytoplasm. This one has a little more cytoplasm than you often see, but it's a good example. Let's look around for some other cells. So here we are a little bit at a distance from that prior point, and we've kind of hit the jackpot here by luck. And I have that rarest of cells, a basophil. So here you can see, as I bring it up in magnification, the very dark purple to blackish looking basophilically stained granules filling the cytoplasm and pretty much obscuring the shape of the nucleus. This cell, like the eosinophil, has a bilobed nucleus, but it's often not very well visualized because these granules tend to obscure it. So there it is, a basophil. So as we look around, what else did we not find? Well, we didn't find a monocyte, so that's our next target. So here I am in yet another little area of this smear, and I've got a nice zone here, a nice field of view that shows me quite a few interesting cells. So right here is what we're looking for. As I zoom up in magnification, you can see that this is the largest cell we've seen so far, and it has this kind of a, well, it's more of a U-shaped. Oftentimes they look kind of more like a kidney-shaped nucleus, but it's the very largest cell, many times, maybe 3 times as big as the RBCs around it, and that is a monocyte. That's the standard for a monocyte. They often do look a little bit distorted. But nearby, we also see this cell, which is a fairly large lymphocyte. Most lymphocytes are only slightly bigger than the RBCs, maybe 10 to 12, at the most, 13, 14 micrometers in diameter. But there's a population of them that can be quite a bit bigger, maybe as big as neutrophils, about 16 to 18 micrometers. Those are large lymphocytes, and those, not always, but typically, if you were to do a specific stain for them, would be NK cells. So there you are, a large lymphocyte. But there's another interesting cell over here. We've got yet another example of more or less the normal-looking lymphocyte. So there's all sorts of neat cells here. Most of them are neutrophils. We've got a very distorted-looking one that may or may not have been another monocyte. It's pretty badly artifactually damaged, so I'm not going to even try to ID it, as well as this one here, and some more neutrophils. So I think we found all of the cells that we need to find in peripheral blood, so we'll move on to hematopoietic smears. So in order to find these hematopoietic cell lineages that we want, we need to look at the bone marrow smears. So here I've got one queued up. This is not the highest resolution that we have. This one is only scanned to about 60, but I think that the cell staining here is a little better. The one that we do have scanned at high mag is a little bit dark for my taste, so I'm going to use this one, and if you need to see it at high mag, we'll use the magnifier. So right away, even at low magnification, I think you can see pretty well that this field of view is just completely loaded with nucleated cells, as opposed to what we saw when we looked at the peripheral blood smear, which had very few nucleated cells. So let's start by examining this and looking for cells in the lineage of the erythrocytes. So I found the first cell in the lineage that you need to know. The lineage that you can recognize actually starts with a very large cell that has a very basophilic cytoplasm called a proerythroblast, but you do not have to ID that one. You're instead going to start with what we call a basophilic erythroblast, which is somewhat smaller. So let's zoom in right here, and this cell right in the middle is the one that has the highly basophilic cytoplasm. Now I'm going to bring up the magnifier and zoom in on that one. You can see that it has that very deeply basophilic cytoplasm, which is pretty agranular, and it has this maroon colored round nucleus. And that's very typical of this particular stage. All of that basophilia is due to a large amount of RER, because this cell is really just a factory for making hemoglobin. Now, as we move around a little bit, we can see some other cells very close nearby that are next in this lineage. For instance, this cell here, which is pretty close by, is what we call a polychromatic erythroblast. So this is the next stage. This cell has been making some hemoglobin, so its cytoplasm is now kind of patchy in appearance. So it's not as deeply blue, and the nucleus is smaller and has what we call a checkerboard or stippled appearance. In some cells, this is really pronounced. Here, that checkerboard is a little iffy, but we can find some better examples as we go along. Here's another example of a polychromatic erythroblast, very patchy appearing scraggly looking a bit cytoplasm with a very stippled appearing nucleus. I think it shows up pretty nicely here. Right underneath that cell is an example of the next stage of development in the erythroblasts, and that is a orthochromatic erythroblast. In this particular stage, the nucleus has gotten extremely small and condensed, almost black oftentimes, and the cytoplasm is either very close or almost identical to the color of the RBCs around it, as you can see here. So you go from basophilic erythroblast to polychromatic erythroblast to orthochromatic erythroblast. So in scouting around, I came across one of those proerythroblasts. So here it is. It's extremely large. It's got that nice maroon nucleus with a very darkly basophilic cytoplasm, but it's quite a bit larger than the basophilic version. Next to it, you can see a very nice example of a polychromatic erythroblast here, with that nice kind of almost a grayish appearance in the cytoplasm, and above it here you can see a orthochromatic erythroblast. So they're really all over the place. As you search through these, you'll see many of these cells. So the next thing we're going to do is to start to look at the granulocytic lineages. So in the granulocytic series, there are the neutrophilic lineages, the eosinophilic, and the basophilic. You will be responsible for identifying the neutrophilic and the eosinophilic, not the basophilic. They're very rare, and if we come across one, that's great, but we're not going to hold you responsible. So the first cell in this lineage is a precursor for all three of those granulocytes, and that's called a promyelocyte. And the promyelocyte is a very big cell, like the monocyte in peripheral blood, which is the biggest cell in peripheral blood. This is one of the biggest cells you're going to see in a bone marrow smear. So I actually came across one. It's over here on the very edge of this smear, and we're going to zoom in on it. So right here, you can see that it's a pretty big cell. It has a large centrally located nucleus, but the really giveaway is that it has these purplish granules. They're often stuck right underneath the plasma membrane. Those are called the azurophilic granules. And those really are your clue. The size and those azurophilic granules are your clue to a promyelocyte. Now, right next to the promyelocyte, we have the first cell after that in the neutrophilic line, which is called a neutrophilic myelocyte. So in the case of this, it's a little bit smaller, as you can see, than the promyelocyte. And the nucleus is what we call eccentric. It's been pushed to the side a little bit. And those azurophilic granules are pretty much gone. You can see that the cytoplasm is taking on the characteristics of a neutrophil. It has that kind of fine granularity without either a very strong eosinophilic or basophilic character to it. So that is the first cell in the neutrophilic specific lineage. So the next cell in the neutrophilic lineage is called a metamyelocyte, and that cell is characterized by having a nucleus with a little bit of a kidney bean shape. So here you can see that kidney bean shaped, a little bit of an indentation. The nucleus is still eccentric, and the cytoplasm still retains those same characteristics that we saw in the myelocyte of this line. So the last cell in the neutrophilic lineage that we're going to look for in bone marrow is going to be the band cell. So what's happening here is that as this cell continues to mature, the nucleus begins to stretch out into a U-shaped. So you're going to see these pretty much all over the place. So that small indentation progresses to this U-shaped nucleus here, and you can see a lot of them around. There's another one over here. They're very common because neutrophils are very common. And this will progress eventually to the lobed version of this, where this U-shaped nucleus will pinch off into several separate lobes, and you're going to see those segmented forms as well. So as we look around, you're going to see a lot of cells you're going to start recognizing. So here's another metamyelocyte with the slightly indented nucleus and the neutrophilic cytoplasm, and another band cell. So as you look around, and then here you have the final version, which is a segmented one. I typically am going to be asking the more mature forms in peripheral blood and these other forms of maturing lineages in the bone marrow smears. So all that remains to be found for us is the eosinophilic lineage, and I seem to have stumbled on an area in this region that has some of those cells we need to find. So first off, we need to find the first cell in the eosinophilic lineage, and that's going to be an eosinophilic myelocyte. So that's going to look very similar to a neutrophilic myelocyte, except for the cytoplasm will be filled with the eosinophilic granules rather than the appearance of the neutrophilic fine granularity. You're going to have that dark reddish appearance. So here's one. You can see the nucleus again, as in the neutrophilic myelocyte, is eccentric, pushed to the side, and you have so many dark red granules packing the cytoplasm that all you can see is the large granules filling that cytoplasm. Now, as luck would have it, there's a second one not far from here. Actually over here, you can see again the eccentric nucleus and all of those dark red cytoplasmic granules just filling the cytoplasm there. And the next in the series is this eosinophilic metamyelocyte. So here you can see the kidney-shaped indented nucleus, and it's packed full of the same red granules as the other cells in this series. Nice example. Lastly, there's an eosinophilic band cell. Now these cells are pretty difficult to find, so I'm going to have to search one out and then start up the video again. So although they are a little more challenging to find, I did come across an eosinophilic band cell. So here you can see it. If I bring the magnifier over, it will be a little easier for you. So here it is. It is stretched out. The nucleus is beyond slightly indented, stretched into kind of a U-shaped. As a matter of fact, this one is tending towards the late stage of the band, almost into a segmented form, but not quite there yet, so we'll still call it a band cell. And of course the cytoplasm is strongly eosinophilic, very dark red. So there you have it, an eosinophilic band cell. So those are all of the cells that you need to identify in these bone marrow smears. So of course you have to remember that along with the cells that we have looked at, the erythrocytic series and the granulocytic, neutrophilic, and eosinophilic variations of that lineage, there are also going to be monocytes that are developing here, lymphocytes that are developing here, and so on. And there's going to be other cell types too, as well as things like macrophages that live here. So you may see a variety of cells as you scout around here, but hopefully this video will help you identify them along with all of the other files that we're going to make available for you to help you figure out this rather complicated topic. So that's all we've got. We'll see you in lab.